Hello explorers and welcome to another video. Today we are going to install Libvirt or Libvirtualization, which is a part of the Linux system. So we already have all of these packages built into Debian and so on. So it's going to be a pretty simple thing to get up and running. And at work we're actually running a bunch of different hosts that have virtual machines running on them. So this is something that we are using quite frequently, and I had no real idea how to set it up and work with it. So I looked into it and tried to create something that could be easily followed. So let's switch over to my screen here. And here we have node 2. This is a part of my Ceph cluster, or at least it was, until like 5 days ago or something like that, when the hard drive that was running on Ceph crashed. So I ran a bunch of work on that. I had to look into SpinRite, running it over and over and again. But there was so many read failures on that drive, so I had to scrap it. And I couldn't use that, which means that I have one node over now that I don't have any use for. So I thought, okay, let's install some virtual machine hosting on it and actually run some of that workload. So let's start this up with just doing a sudo apt update. So this is a newly installed Debian host. I reset it. So there is nothing extra installed on this. It's just Debian. And I realized that this is a machine that is actually on my network, a real machine. So it has a real password, of course. Then I want to install a couple of packages here. So first off, we want to have the KVM package. So we have a KVM virtual key management solution here. Then we want Libvirt daemon for system V. We want Libvirt daemon driver storage RBD, because I'm going to set up an RBD pool later on. And we also want the QEMU block extra, which has some extra packages to handle block devices. And then bridge utils for our bridge network. So those are the packages we need. This will take a little while to install. And now all those packages are installed, and we can also see here that it has set up a couple of services that are running. So virtlog and virtd and so on, which is running now. So we could actually log in and use this virtualization tooling. We could also, of course, run virtualization shell list, so we can list which host we have installed. For the bridge network, to set that up, we need to configure a file called syscontrol bridge conf. It's not available at the moment, but I'm going to create one of those and add these calls into this. And this is turning off some functionality, and it's the IP tables that are built into Linux. We could set up firewall rules that actually handle how traffic should be routed inside of your system. And for more specified and more secure solutions, you might want to set this up. But if you want more performance and you put this behind a firewall and want to have just clean and easy access to this machine, you can just turn these features off. So I'm going to turn IP tables routing off on this machine. And in order to enable that, we also need to create a file in the udevd, and I call this 99 bridge rules. And here I will put in an extra rule, so an action add for the module brnetfilter. This is the new way of doing this since kernel 3.18 or something, so it's not that new. And then it should just run syscontrol with this bridgeconf file. So adding that, it should turn those features off. Next up, we also need to figure out the actual MAC address of our system, and I found this command. So we run IP address show dev and then eno1, which is my network interface, and it will awk looking for this link ether, and then I have this MAC address. So this is something that we need to use later on when we set up our network interfaces. So now we go into the network interfaces, and here we already have some configuration for So Eno1 is just an interface using DHCP. And I already know which address this should have and so on. So I will remove these lines and I will replace them with a lot of extra, but I'm gonna talk about what I actually add here. So this is the full block that I will add. So I will continue having Eno1 hot plugged. I will automatically mount it up. So Eno1 interface, I will set that to manual. And then I will create a new interface here called BR1. So this is our bridge interface. It should have a static address. And then I say that it should be used this hardware address. So this is the MAC address we found earlier. I set up a particular IP on my system. So this is 18. This is one that I have dedicated for this host on my network. And then a net mask and the gateway is of my network. And this will be something that is bridging over this interface. So bridge port should be Eno1, and then you could use spanning tree protocol. I turned that off at the moment, and I also set that to 0 down here. So this is a very simple configuration for this. There is a bunch of things that you can do to configure it differently, but this is a way to just traffic things from different virtual hosts inside of your system, so they get their own IPs on your local network. And save that down. So now we have that. The reason I copy pasted this, big reason I did that, is because I want to reset this interface live through SSH. And if you don't do that correctly, you need to reboot your machine, put in, so I actually have some view of it, because the interface will of course be gone, and if it's not correctly configured, I can't log in anymore. So just resetting it now without a restart, you can do IP address flush Eno1 scope global, so it will remove all the configuration of Eno1, and then it will bring up this BR0 interface. And we'll do that with sudo here. So that should bring it up. And now if we run IPA, we see that we have BR1 instead that we are connected to now. And Eno1 has no configuration at all. So this means that we now are on the bridge interface and can start using that. Another part is that I have actually went in as root on this machine. And I have added authorized keys as root. Let's do sudo su like that. And here in my SSH, I have added authorized keys, one of my public keys that are available on my system. So I can log in as root on this machine without having any passwords. So that is important to get a simple view here. So there is a package that I can install called Virt Manager that I install on my local machine, and it looks like this. So here I can actually connect to something, and here I already set up node 2. What you do is add a connection. You connect to a host over SSH, and then you put in the name of it, in this case node 2. And that will connect to it over SSH. And if you have put in this key, you can just connect to it and don't add any password. You could have just password here, but the problem is that you need to log in as root, and having availability to log in as root with password is not secure. So having a key that you connect root to is more secure, and is the way I will go here. So now I connected to this node here, and here I can actually create new machines now. So I could install a totally new machine here, but I want to put in an image so I can actually use that. So I will go into my Ceph VBox here. So here I have a bunch of different machine images. So I will SCP Debian 12 to root node 2. So put that over on my node 2. And that needs to be copied into the Libvirt image folder, so it is actually available and viewable in the system. So if we go back to node 2 here, we can jump into that directory. It's empty at the moment, so it's in var lib libvirt images. So here it will store images and create images locally if we want to install a new machine. So let's see, it should be copied there. And then we can just move it into this directory here. And if I now go back to this virtual machine interface here, I could go into this and look at details. And here we have the overview, we have our virtual networks here, and we have storage. And we see here that I have a default storage, and I have 16 gigabyte free at the moment to put images on. That's not much. I would much rather have a lot more space to create a virtual image if I want to run a system on this machine, of course. So what I want to do now is connect Ceph, so I can actually have a virtual host here. So if we go into my Ceph here, I have a bunch of tutorials on how to install Ceph, so I will not go through that. But here we see that I have a pool already ready called images. To create pools, you just go in here, type a name, and then select the pool type replicated, for instance. I have 3 copies, and then you need to select RBD here. So that's the important part to set up a pool. But I've already prepared that, so we already have this images pool, and it's an RBD type and ready to be used. If we go into my node 3 that has access to this, what you need to do is run RBD pool emit images. I've already done that, so it's prepared for that workload. Then we need to create a key that we can log in with. So we use Ceph auth get or create client Libvirt. So that's the name of the client account. Then it needs to have access to the monitor for a profile of RBD. It needs to have access to the OSDs with a profile of RBD and to the pool of images. You could say that you just have profile RBD, so it will have all the pools that is available for RBD. But in this case, I want to be more specific and say, okay, this host should just have the images available. So then I get this key. You can run this command as many times you want because it's a get or create. So this key is already created for me. But if you want to create a new key, you can do it like that. Then I need to set up a secret for Libvirt. So we go to the root directory here again, create a secret, secret, and this file is just a way of creating something that is in the system, pretty much. So just say that I should create a new secret. I need to give it a unique identifier. The usage should be Ceph. It should give it a name. Doesn't really matter, but I say that this is a client Libvirt secret. So I create that file here, and then I will define that secret. So virt sh secret define with the file secret.xml, and after we have created that, we can set a value to this. And I will run this command on the command prompt. It's not really secure to have the key in the command prompt, but for that now it's just fine. So virt secret set value secret, and then the actual unique identifier that we used earlier, base 64, which is the encoding this comes in, and then the actual secret key. So we will set that value, and it tells us that this setting it on the command line is not secure. It's insecure. So if you're running this command in any production, go into history and delete that entry so you don't store a password in your logs. And now we can set up the pool. So let's go into the manager again. And here under pools, we have a plus sign down here. So we'll take that. We can say that we have a Ceph system. We can select Ceph in the list here. It's an RBD Rados block device Ceph. The host name should be node 2. And the source name should be images. So that's what we want to set up. But this particular pop-up here, this dialog, doesn't have all the things that we need because we need to add a secret as well. So we go into XML mode, so now we can see what we have entered so far, and we need to add the authentication as well. So on the source here, I will add this extra here. So auth, type Ceph, username Libvirt. So we don't add client there. So client is just a way for it to namespace the different usages in Ceph. So Libvirt is the actual name of that client. And then the secret we should use is this unique identifier. So now, if we have put this in correctly and I click finish here, it should be able to create that storage pool and give me access so I can create virtual images in this system with a lot more storage potential. And we are back. I did a little bit of a dumb thing there. I had to restart the service in order to log in again and get it up and running. What I did was that I said connect to the Ceph node 2, and node 2 is not running Ceph. So it should be node 3, of course. So now we see here that in our default system here, we have the Debian image here, an ISO image, and we have 16 gigabytes free. Then we have this Ceph block device here, which have 18 terabytes free to create images on. And you see here that I should of course have host node 3, which is one of the nodes available in my Ceph cluster. So now I could create a new image here on Ceph. So let's go in here. Let's create a new volume, call it test. And we could have 20 gigabytes there of free space. So now it's created this raw volume here. If we now go back to the host machine here, I can create a new. And we have this dialog here. Let's do a manual install. Let's forward that. It should be a Debian system, so Debian 12. And then it suggests 2 gigabytes of memory and 2 CPUs. Sounds great. I will not create an image here. I will just select one. So I will select from the Ceph storage, test, choose that volume, forward. And here I can do a network solution section. I can say that I want to use BR1 and BR0. That will be that. And I will customize the configuration before install. Now, when we finish this here, what I want to do is actually add that boot image. So I go in under this menu here, create a new hardware. And a storage hardware, I will select a CD-ROM. And I will select this image here from my pool, choose volume. So now I have selected it, custom storage, CD-ROM and SATA, and then finish that. So now I have this SATA CD-ROM here, and I can go in on the boot option, select that and push it up so it's the first boot option. So now I should be able to begin the installation here. I will apply this and begin installation. This will open up a virtual machine with the graphical install here. And with a little bit of luck, it will start installing a Debian system on a virtual host, running on a different system or a different host machine than my own over Libvirt and storing its result on Ceph. So what we can do now is look in the Ceph system here under images. And here we have that image. This test image has been created in my block storage pool with 20 gigabytes of available storage. Currently it has 5K objects of the size of 4 megabytes. And not much usage so far, but it's currently starting the installation process here. And we are back, and it's a couple of hours later. And yeah, I didn't wait for it to finish. This was a totally automated install. And you see that the guest is currently not running. If we start it up, we should get into a Linux system. Oh, wait a minute. We can't start it up. We will force it down. Very important here. We need to go into details. We have this CD-ROM still in here. I will remove that hardware. To ensure that we don't start up with that in in the disk. So let's start it up again and go back here, and then we should get a Debian boot instead. And it should be booting into a Linux environment that we could use for whatever purpose we want. So that is now installed in this virtual environment. Let's jump out of this and go to my web browser here. And here we can see that we have this test image. Currently it has taken up 2.7 gigabytes of disk space. Still, it's using the same 5.1 K objects of a size of 4 megabytes. So it's still in there and still prepared to take even more data, but currently we haven't used up the full disk. And currently we are cleaning the disk, but as you see, it works just fine. It's not the fastest because of the limitations of both the hardware in the actual machine. It's just a quad core with 8 gigabytes of memory, so a very small machine. And we also have a very slow network between the Ceph cluster and the machine, and so on. But if you have a decent network, decent drives in your Ceph cluster, and also some really good hardware to run your virtual environments in, this is a totally feasible solution to run a lot of different virtual machines. So this was what I wanted to cover today. I hope that you found this interesting. I hope that you liked this video. Give it a like, share it with your friends and colleagues. If you have any comments or suggestions, leave that down in the comment section down below. If you haven't subscribed yet, please do that. And I really hope to see you in the next video.